Welcome back to another lesson in MCR3U. Today we'll be talking about simplifying rational expressions. So first let's define what a rational expression is. A rational expression is a quotient whose numerator and denominator are both polynomials. Some examples are listed here. So 7 over k minus 1, a squared plus b squared over a plus b, y minus 5 over 7, 6g over g squared minus 3. Our goal is to simplify these expressions as much as possible using various techniques. One important note, and something that's different, is when we're simplifying rational expressions, you must also state the restrictions in the variable. So we have to state restrictions in the variable, which is different than maybe previous courses that you have taken. It is best to keep on a running list of all the restrictions throughout each problem instead of trying to write them all down at the end. In mathematics, again, it's possible to multiply by zero, but it's not possible to divide by zero. So in rational expressions, restrictions apply when the denominator is equal to zero. So denominator is equal to zero. That is, any values for a variable that result in the denominator having a value of zero are not acceptable, and those are the restrictions that we are going to place on the expression. So let's take a look at these examples here. So it's simplifying the following rational expressions and state the restrictions on the variable. So here, we're going to have 30x to the power 4, y to the power 3 over negative 6x to the power 7 and y. And so if we look at the restrictions here, what values would make the denominator equal to 0? First, if x was equal to 0, that would make the denominator equal to 0. So again, x cannot equal 0. And also the same thing with y. Y cannot be equal to 0. So the two restrictions we have here are x cannot be equal to 0 and y cannot be equal to 0. Once we do that, we can just solve the equation as it is. 30 divided by negative 6 give us negative 5. Using exponent rules, we have x to the power 4 divided by x to the power 7. This gives us x to the power of negative 3. Y to the power 3 divided by y to the power 1 is y to the power of 2. Remember here with exponent rules, anytime we're dividing, we are subtracting the two exponents as long as the base is the same. Here we have 10x to the power of 4 minus 8x squared plus 4x over 2x squared. So first thing we're going to do, we're going to see if there's a common factor in the numerator. There is, which is 2x. If we factor 2x, we have 5x to the power of 3 minus 4x plus 2 divided by 2x squared. Here, we can cancel out the 2x from the top and the bottom, and we'll be left with 5x cubed minus 4x plus 2 divided by x. And here, restriction is that x cannot be equal to 0. Okay, let's continue with this third example here. So we have 2x squared plus 3x minus 2 over x squared minus 4. If you look at the bottom, you can recognize that this is going to be a difference of squares. And so here are kind of three steps that we want to do. Again, number one is to factor both the numerator and denominator. Once we factor the numerator and denominator, we want to state the restrictions. And finally, then we want to simplify. So here we have 2x squared plus 3x minus 2 being a complex trinomial. Simply factor that the way that you prefer. Again, either using the crisscross method, the slide and divide method, or decomposition. Regardless of which way you use, get an answer of 2x minus 1, x plus 2, and in the denominator we'll get x minus 2, x plus 2. Here we want to state the restriction. So we see that x cannot be equal to plus or minus 2. And now we can cancel out the x plus 2, and we'll be left with 2x minus 1 over x minus 2. Okay, so here, question number 4, example number 4, x minus 7 over 14 minus 2x. Then we have a common factor of negative 2 at the bottom. So here we'll have x minus 7 over negative 2, x minus 7. Here we see that x cannot be equal to 7. Now we can cancel these out. And our answer is equal to negative 1 over 2. Okay, continuing on. Here we have two simple trinomials, x squared plus 2x minus 8 divided by x squared plus 7x plus 12. So we'll factor out first. Here we factor out x squared plus 2x minus 8, be x plus 4, x minus 2. On the bottom, x squared plus 7x plus 12 will give us x plus 4, x plus 3. And now we want to state our restrictions. So restrictions here, x cannot be equal to negative 4 or negative 3. And so here we can cancel out the x plus 4 now, which will leave us with x minus 2 over x minus x plus 3. And continuing on, here we have 2x squared plus x minus 6 over 6x squared plus x minus 15, two complex trinomials. So we'll factor both of those out. When we factor 2x squared plus 8x minus 6, we'll get 2x minus 3 and x plus 2. On the bottom, 6x squared plus x minus 15, we'll get 3x plus 5 and 2x minus 3. So here, we'll cancel out the 2x minus 3. State the restrictions first actually here for 3x plus 5 and 2x minus 3. So here again, x cannot be equal to negative 5 over 3 and 3 over 2. From that, you're going to find an answer of x plus 2, 3x plus 5. And finally, these few examples here. So a little bit more complex. So here we have negative x squared minus 5x plus 6 over x plus 6. First thing we'll do here is we'll factor out the negative from the numerator to make it a bit simpler to factor. So we'll be left with x squared plus 5x minus 6 after factoring out the negative 1. And at the bottom, we'll have x plus 6. From there, we can state our restriction. X cannot be equal to -6. Factor at the top, left with x plus 6, x minus 1, divided by x plus 6. Here we can cancel out the x plus 6. We'll be left with negative x plus 1, or if we expand that in, you get negative x minus 1. For b here, we have y over 4y squared minus 12y. First thing we'll do, common factor 4y from the bottom, left with y minus 3. So here, two restrictions. Again, the 4y means that y cannot be equal to 0, and y minus 3, which means that y also cannot be equal to 3. So now we can cancel out the y from the numerator denominator, and we'll be left with 1 over 4y minus 3. And you can expand that in if you like. So 1 over 4y minus 12. But we can really just keep it as 1 over 4 bracket y minus 3 as well. So here we have 5 minus 4x over 8x minus 10. Here we'll factor out a negative from the top. That'll leave us with 4x minus 5. Factor out a 2 from the bottom. Leave us with 4x minus 5. So here, our restriction, x cannot be equal to 5 over 4. Cancel out the 4x minus 5. That gives us negative 1 over 2. Here for d, we have 3p squared plus 10p minus 8 over 6p squared minus 7p plus 2. First thing we'll do, factor the numerator, factor the denominator. And that will give us 3p minus 2, p plus 4. And at the bottom, we'll be given 3p minus 2 and 2p minus 1. So now we can state our restrictions. Here, p cannot be equal to 1 over 2 or 2 over 3. Cancel the 3p minus 2, and we'll be left here with p plus 4 over 2p minus 1. And then last few questions here. We have 4 minus 9y over 6y squared minus 4y. Here, first thing we want to do, factor the negative from the top, which will give us 9y squared minus 4, which we notice is a difference of squares, over 6y squared minus 4y. Now we want to factor. Again, factor the difference of squares. We'll get 3y minus 2, 3y plus 2. Remember square rooting the first term and square root the second term. That's like entering the difference of squares. And at the bottom, we can factor out a common factor of 2y, which will leave us with 3y minus 2. Now to state our restrictions, y cannot be equal to 0, and 2 over 3. So here we'll be able to cancel 3y minus 2, and we'll be left with negative 3y plus 2 over 2y. And here we can factor in if we'd like. Give us negative 3y minus 2 over 2y. Finally, this last question that we have here is 2p squared minus 5pq minus 3q squared over p squared minus 5pq plus 6q squared. So here, as we can see, again, they are in the form of complex trinomials. Again, this one involves two variables, so a little bit different. But again, we can just factor it the same way that we generally factored complex trinomials. So here we have the first complex trinomial of 2p squared minus 5pq minus 3q squared. We factor that out. We'll get 2p plus q and p minus 3q. On the bottom, p minus 2q and p minus 3q. So you notice how there's two variables that are in this question. And when you state the restriction, you can just state it with respect to one variable. So here we have p cannot be equal to 2q, and p can also not be equal to 3q. So as you see, we have it with respect to this one variable here. Now we can cancel it out. P minus 3q. We're left with 2p plus q over p minus 2q.